Hi, welcome to this 8th lecture section of the course Database Management Systems. In the previous lecture session, we started discussing about SQL. We have seen the history. We discussed about the features that are supported by advantages of SQL, and then we started discussing about the DDL commands, that is data definition language set of commands, using which we can define the structure of the database. That means we can create tables, we can add constraints, we can define the format for attributes and key constraints like primary key and foreign key, all these things. Then we started discussing about DML set of commands, that is data manipulation language set of commands, using which we can query the data, we can insert new tuples into the database, we can delete some tuples, and then we can update the tuples available in the database. First we started with querying the data, that is extracting data from the database. In that we have seen what is the generic form of the SQL query, which comprises of select, from, where clauses, and then we have seen how to write queries with joining two tables to extract the data which is spread across multiple tables, and then how to specify the join condition in where clause. Then we have seen how to make a string comparison using percentage and underscore characters, and we have seen how to use the clause, that is the keyword order by, using which the result of the SQL query can be displayed in a particular order based on the value of some attribute, either in descending or ascending order. Now in this lecture session, let us continue further. We will discuss the nested queries and correlated nested queries, and use of exists and not exists clauses in SQL, and explicit join operators. That is, whatever we have seen so far in the previous session, the joining was happening by specifying some join condition in where clause, and SQL also supports some clauses or keywords using which we can perform explicit join operation. Then we will see what are the aggregate functions that are supported in SQL, how to use group by function and group by clause, and what is having clause, which can be used in conjunction with grouping. At the end we will see how to insert tuples, how to update tuples, and then how to delete the existing tuples from the table or relations, and finally we will discuss very important concept, that is views supported by SQL. First we will discuss nested queries. If a query appears inside another query, it is called as a nested query. For example, if you look at this is the outer query, and whatever is written here which is underlined, that is a separate query which is part of the outer query. This one is called as the nested query. For example, we need to retrieve the name of each employee who has a dependent with the same name as the employee. Let us assume that the situation is such that an employee can have a dependent with same name as himself. That could be the case. In such case, then how can I do this? I can write this using a nested query. Select here in from clause, I am specifying employee table as E, that is I am giving a alias name for the employee table or employee relation. Select E dot first name from employee as E, that means E means the employee table which is specified in the outer query from clause, where E dot SSN, for what kind of employees I will be displaying that? The employee should have a dependent, and he must have at least one dependent with same name as himself. So that should be the condition. That is why in where clause I will write E dot SSN in this in clause or operation. It is going to check whether the given value is in the given set or not. If you execute the nested query, if we execute the nested query, this one, what is this? Select ESSN from dependent, that is from the dependent table I am selecting on ESSN, where E dot F name is equals to dependent dot name. This E dot F name is part of the outer query relation, that is employee. That is why E is a alias name given to the employee. E dot F name refers to the outer query employee relations F name or first name. That means I will go to dependent table and I will check whether a dependent name is same as that particular employee's first name or not. If such is the case, such ESSNs will show up in the result of the inner query, that is the nested query. That means let us assume that it will have some 101, 108, 109 and then 114, something like that. That means these are the employee ESSNs where the first name of the employee is same as the dependent name. For such, and in this where clause, this will check whether this E.SSN is in this set or not. If such is the case, then it will display that employee's first name in the result. And to check then we have another kind of nested query which is called as a correlated nested query. Whenever a condition in the where clause of a nested query references some attribute of a relation declared in the outer query, then the two queries are said to be correlated, and that nested query is said to be correlated nested query. In this specific example, it is a correlated nested query. There is a correlation between outer query and then inner query, because the whatever this E.F name, which is the attribute which is being used in the inner query, that actually taken from, that actually refers to the relation attribute which is part of the relation which is specified in the outer query. That is why this outer query and then inner query are said to be correlated. Let us have a look at another example, and which will give us a better idea about these nested queries. Assume employee table with employee ID, employee name, age and then D number. We have department table with DNUM, DNAME and another attribute called MGR, which is a foreign key which actually refers to this employee ID, indicating that who is the manager of the given department. Now we need to get every employee's employee ID and name for those who are working with the accounts department. For this, I can write a nested query. Select EID and ENAME from employee where D number is in. I am writing a nested query. What is this? Select DNUM from department where DNAME is equals to accounts. This is not a correlated nested query, because if you carefully observe the inner query, I am not referring to any of the attributes that are part of the outer query. So that is why it is not a correlated nested query. If it is not a correlated nested query, then it could be a one-time execution. That is, now suppose if I have 101, 102 and then 106, something like employees like this, according to this outer query, every time it will take one tuple or one employee information and it will check whether the D number is in this set or not. What is the result of the inner query? If you execute this select DNUM from the department where DNAME is equals to account, it will give you a set which contains the result of this, that is D numbers. Let us assume that there is a department number 10 whose name is accounts. So it will be 10. Now in the outer query, every time, that is in each iteration, it will take information about, that is it refers to each tuple in the employee table, that is the outer query relation, and then it will check whether the DNO of the tuple is in this set or not. If it is there in that set, then it evaluates to true, and then such employee ID and then employee name will show up in the result. That means in this case, the employee ID, let us assume that there are 101, 104 and 110 are the employees. This fellow A, B, C are the names. This fellow works with 10, 20 and then let us assume that this is 10. Then I have 10 and 20 and the name of the 10 is accounts and then 20 is marketing. Now according to the outer query, first it will take the first tuple and then because it is not a correlated nested query, the inner query can be executed only once. So you execute it any number of times, the result is going to be same. So what is the result? This will result in the account number where the department name is equals to, the department number where the department name is equals to account. Of course the result is going to be 10. Now as part of executing the outer query, first it will take the first tuple in employee table and check whether DNO is in this set or not. Of course this particular set contains only one element. So DNO is in this or not. For the first tuple, first employee, the DNO is equals to 10. It evaluates to true. So 101 and A, that will appear in the result. Next time in the second iteration it will take the second tuple and this time the department number is equals to 20. It will check whether it is in this set or not. No, it is not there, so it is false. It will not appear in the result. And 110 whose name is C and the department number is equals to 10. Yes, this is there in this set, so it will appear in the result. So 110C. Now this is going to be the result for the given query. This is called as the nested query. But of course, in this example, whatever I have written, the nested query is not a correlated nested query, since I am not referring to any of the attributes that are part of the outer query relation that is specified in the outer query. So that's why it is not a correlated nested query. Now let us have a look at the example for the same thing. I can sometimes I may need to write some correlated nested query. Again, same employee table and then department table with same structure. Now the requirement is slightly different. Get employee ID and then name for those employees who are managers. Okay, how can I know that they are managers? If he is a manager, the value of employee ID will be there under the column MGR in department table. So I can write a correlated nested query here, and here in from class I am referring to employee table and then giving it a alias name, and it is called as E. Select E.EID and E.ENAME from employee as E, where I am using a specific class that is exists, where exists select star from DEPT, where E.EID is equals to manager, and it is a foreign key which is pointing to employee ID. So what is this inner query? I am getting all the tuples from department table, where the manager value for the department tuple is same as the employee ID of the tuple which I am referring to from the outer query relation. Okay, let us assume that I have 101 and 106 and 110 are the employees, and then every time it will take in the as part of executing the outer query, every time it will take each tuple. First time it will take the first tuple and then it will execute this. When it is first tuple, when it is executing this, every time depending on the tuple it is considering in the outer query, the value of E.EID will change. That's why when I am referring to an attribute which is part of the outer query relation, then it is called as a correlated nested query. Then one time execution of the inner query is not possible, is not correct, and every time the E.EID value will change. For the first tuple, the E.EID is going to be 101 and it will check, and let us assume that I have department number 10 and 20 which is accounts and then marketing. The manager is equals to 106 and the manager is equals to 110, and it will check whether it is there any tuple where 101 is there as MGR attribute in department table. No such tuple exists, so that's why there will be no tuples in the given set of this particular inner query result. That means then this exists clause will evaluate to false. This exists clause will evaluate to true when we have at least one tuple or one element in the resulting set which comes after this exists clause. So when it is 101 employee ID and there is no tuple matching tuple in the department table, so it is going to be null. Then for 101 it will not show up in the result. Next time it will take 106. Now this will become 106 and it will evaluate this. Yes, there is a tuple with department number 10 where the manager is equals to 106. It will get one tuple, that is one tuple will be there in this. That means exists evaluates to true. Hence the 106 will show up in the result and his name will also show up in the result. Then it will take 110 and now EID becomes 110, and again there exists a tuple in the department table where it matches with the present employee ID. Hence the 110 will also show up in the result along with his name. This is called as a correlated nested query. Similarly, how we have used this exists clause, we can also use not exist clause which works exactly opposite to the exist clause. And for example, the requirement is retrieve the names, salary of employees who have no dependents. Okay, and when we can say that an employee has no dependent, if there is no entry for the given employee's ID in the dependent table, that indicates that he doesn't have any dependents. If he is having at least one dependent, definitely there will be at least one entry in the dependent table with that given employee ID as attribute ESSN in dependent table. Okay, now select FNAME salary from employee table where not exists. When I execute this is going to be a correlated nested query because this SSN is an attribute which belongs to this outer query relation and ESSN is the attribute which belongs to inner query relation. So for every tuple in the outer query, that is employee relation, and every time the SSN is going to change, and every time it will check is there any tuple available in dependent table with SSN is equals to ESSN, and if something is there, at least there will be one tuple or one element will be there in the resulting set, and then not exists means what? If nothing is there, then only it should evaluate to true. It is exactly opposite to that of the exists clause. So suppose if 101 is the employee who is not having any dependent, then this execution of this inner query for the employee SSN 101, it will result in no tuples. That's why this not exists will evaluate to true. For that employee, the name and salary will be displayed, and we can also use exists. Just now we have seen some example how to use the exists clause, and it is also possible to use an explicit set of values in the where clause. Okay, that is also possible. And we can say that I want to find out the employees who are working with either department number 5 or 10. I can write it like this: select employee ID comma name from EMP table. Let us assume that the DNO is part of the employee table, where dnum in, I can clearly specify the set 10 comma 5, that it will check whether it is in this set or not. If it is available, then it will evaluate to true. For such employees, the employee ID and name will be displayed in the result. That means the explicit set of values can also be used in the where clause. That is possible, and we can also check whether a value is equal to null or not. That is also permitted. Then we can perform renaming of attributes in the result. Okay, suppose there is a attribute called ename in the employee table. Now I would like to see it as, and if I don't use this, and if I am using this, suppose, okay, we assume that the name, there is an employee table with employee ID, name, and then DNO. Now I would like to find out the names of the employees who are working with department number 5, but rather than showing it as name, it should be displayed as EMP underscore name. And if I don't do this, simply if I write this query, it will display the result like this. There will be only one column, that is the title of the column is name, and it will give you the names of the employees who are working with department number 5. But I would like to see it as EMP underscore name. Then how can I do this? Select name of employee table and display it as EMP underscore name, where DNO is equals to 5. This is how I can change the title of the or label of the column in result. Then we can also use the join operations. So far whatever we have seen in the beginning, that is, I can join the tuples which are spread across multiple tables by specifying the join conditions in where clause. But SQL also supports explicit joining operations, wherein for normal join I will be using the keyword join. For performing natural join, I will use the keyword natural join. For left outer join, this is the keyword. For performing right outer join, this is the keyword I can use. Let us have a look at the examples. Let us assume this scenario wherein I have employee table and then department table. Employee ID as usual, employee ID is the primary key, ename, age, and then DNO. dnum is the primary key of department table, and which is being referenced by DNO, which is a foreign key in employee table. This is the foreign key in employee table which is referencing this dnum of department table. Now I need to figure out the employee's ID and then name for those who are working with the department accounts. If it is normal case, if I am going to specify that join condition in where clause, I can write it like this: select EID comma ename from how many tables I need to access? I need to access 2 tables, because in the employee table I have only D number, that is, which is a foreign key pointing to department table, and the actual name of the department is available in department table. So I need to access 2 tables from EMP comma department. In where clause I need to specify the join condition. First I need to join the tuples which are spread across these two tables. What is the join condition? That means there should be a common attribute among these two, where it can, using which we can perform a joining operation to club the tuples or join the tuples. So the join condition is DNO in employee table is equal to DNUM in department table. And what is the other condition? Once you perform this, it will result in a big tuple, where the tuple will contain all the attributes of employee table as well as the department table, and of course the value of DNO will be same as the DNUM. And after getting that larger tuple, from that tuple I need to figure out or filter out only those tuples where the value under DNAME attribute is equal to accounts. So this is a very normal case of a very usual way of joining the tuples which are spread across the multiple tables. Now instead of doing this, let us try to use the join keyword to join the tuples from multiple tables. Okay. Same thing I can write it like this: select employee ID ename from the joined tuples. What is the joining? Join EMP with the department, that is EMP join. I am using, this is the keyword that should be used to perform normal join operations. Join, that is in from class EMP join department, and next I need to specify what is the join condition. Join on DNO is equals to D number, and close the parenthesis. When you perform this, the join operation is performed and it will generate a bigger tuple. From that tuple, on the tuple I will be performing a condition check where DNAME in the tuple should be equal to accounts. For such tuples you will find out, you will only display the employee ID and their name. The first example is for simple join operation. I can also perform natural join, but only requirement for performing natural join is the attribute name should be same, then only I can perform the natural join. Okay. Now of course I am going to join these two tables based on this DNO and D number, but unfortunately in this case the attribute names are different. Now what should I do? The one way of making it possible is rename the department table attributes and then make sure that the DNO in employee table will be same as the D number, that is modified name of D number in the modified table. So that's why here if you carefully observe, select EID ename from, this is the joining operation. In this join I am performing natural join from EMP natural join. This is the keyword I need to use to specify natural join operation. Natural join with what? Department. As it is, I cannot perform natural join with the department, but I need to modify the department. I should take the, consider department in a different shape. So department, as I am giving it a different name, DEP, and now DNUM will become DNO and DNAME will become DEP name, that is department name. Now the new shape of this department will be, it is like DEP and then DNO and then DEP name. Now since the we have common attributes and the domain is also same, now I can perform a natural join, and once the natural join is performed I can check for this condition, that is DEP name is equal to account. For such tuples I need to show up the employee ID and ename. That is about natural join operation. Similarly we can also perform the outer joins. Left outer join and right outer join can be performed. In this example I am just giving how to perform left outer join. Select EID ename from EMP left outer join with the department table on DNO is equals to D number. Similarly I can also use right outer join. If I am using left outer join, all the tuples in the right hand side relation, left hand side relation, which is the left hand side relation? EMP. That means all the tuples from EMP table, independent of whether they have a corresponding matching tuple in the right hand side relation, that is department table or not, all of them will show up in the result. If it is a right outer join, all the tuples in the right side relation will be seen in the result. This is how to perform left outer join, right outer join, and natural join and simple join using SQL. Okay, now we have done with this discussion about the join operations. Now we will see, like what we have seen in the case of relational algebra, SQL also supports aggregate functions. Like they are same: average, minimum, maximum, finding the sum, and then count. Count will always result in or give you back the number of elements available in the set, and they are called as aggregate functions because independent of the number of elements available in the set on which this aggregate function is operated, it will result in only one value. So sum, it could be 1000 values, still the sum is going to be only one value. So that is the basic characteristic of this aggregate functions. Okay, we can use aggregate functions like this: select, sum the attribute value, that is for what attribute values you want to find out the sum on salary value, and I need to find out average on salary from employee table. Then it will go to employee table and pick up all the salary values for different employees and find out the sum and display it there. And also it will pick up all the salary values and then find out the average. So what could be the result? It will be like, it is a table where the first column is going to be sum underscore salary and second one is going to be AVG underscore salary. There will be only one row because I have performed the aggregate operation. It will result in only one value. That's why in this table there will be only one row. To retrieve the number of rows in a employee in the employee table, I can use this. Select count star. Count star means what? It will count the tuples available in employee table. Then retrieve the name of employees who have two or more dependents. Then I can write the query like this: select fname from employee, where I am writing a inner query. Select count star from dependent, where SSN is equals to ESSN, and this inner query is a correlated nested query because here I am referring to one attribute which is actually specified and then which is part of the outer query relation. That's why it is a correlated nested query. And when you execute this, that is for every employee, each time it will take each employee and then SSN will become the employee ID of that particular employee, and then it will check how many count star. That means first what it will do, this inner query will check how many dependents are there for the given employee, and that many number of rows will be there in the dependent table as a result. So it will check whether that count star, that will give you the number, how many tuples are there, is greater than or equal to 2 or not. If such is the case, then for that employee the first name will show up in the result. This will tell us how many the names of the employees who have at least 2 dependents. This is how we can use the count star operation, aggregate operation. And another important feature of SQL is I can use group by function, and of course it is similar to that of the group by operation that what we have seen with the relational algebra grouping operation. And when we use this group by class, it is going to group the tuples in a table based on the value of some grouping attribute. The grouping attribute could be one attribute or more than one attribute. Okay, let us take a simple case. I would like to find out for each department how many employees are there. To answer this query, I need to access only one table, that is the required information is available in employee table alone, because in employee table I have department numbers available. That means in the result I want something like this: what is the department number and then how many are there, count star, that is how many tuples are there, and the number of rows in the result will be equal to the number of distinct department number values. If you assume that there are 10, 20 and 30 are the department numbers available, so you will find 10, 20 and 30, and we also assume that there exists at least one employee for each of these departments. Okay, then if you execute this, then it will go to the employee table and group the tuples, employee tuples, based on what is the grouping attribute here. DNO is the grouping attribute because I am specifying it as group by DNO, that is the grouping attribute. Then it will group the tuples available in employee table based on the DNO value. Now let us assume that at least one employee is there for each department. Then at the most it is going to create, if there are 3 departments available in the department table, at the most it will create the 3 groups. 3 groups are available. Now after applying this grouping, then it will perform the aggregate operation. When you are using aggregate operations on grouping in conjunction with the group by class, then first grouping is performed, then on individual groups the aggregate functions will be evaluated. So that's why first grouping is done based on the department number. On individual groups, now I have one group for department number 10, another group for 20, another group for 30, and of course there may be some employees available in each of these groups. Depending on the number of tuples will be there in each of the groups. Count star means it is going to count the number of tuples available in each of the group. If there are 50 employees under 10, then it will display it like this. If there are 30, here like this. If there are 25, it is like this. So first grouping is done, then the aggregate functions will be applied on this individual groups. This is how the grouping and then aggregate operations functions work. Then we can use the having clause in conjunction with group by operation or group by clause. For example, we need to retrieve the department number and number of employees for the departments which have more than 5 employees working in it. That means I need to display the department number and number of employees working in the department. And what is the other condition? The department must also have at least 5 employees. It should have more than 5 employees working in it. How can I do it? That means this is this having clause is going to work like the where clause. The where clause is going to test or check for some condition satisfaction on individual tuples, whereas the having clause is going to check that the condition on groups. Okay, that's why the having clause must be always used in conjunction with group by clause. It cannot be used individually. So that's why select DNO and count star from employee, group by department number, and having count star greater than 5. So when I am using these aggregate functions and group by, first grouping is done. When you execute this, first grouping is done based on the department number, and then for on individual groups this count star will be applied because it is there in the having clause. Having clause is there to check some condition on the individual groups. So that's why after grouping it will check count star means how many tuples are there in each group, and if it is greater than 5, only for such groups it will perform the count star. Then it will find out what is the total number of tuples in that star, and along with the department number, that is which is a grouping attribute, along with the department number it will display the number of employees for that group, and wherein the minimum number of employees available in that group is greater than 5. So this is how we use the group by clause and then having clause. We are done with DML commands. Okay, the first DML commands, that is to retrieve the data or extract data from the database. Now we will have a look at other kinds of DML commands, and the next set is to insert new tuples into the table, and this is the general format. Insert is the keyword that need to be used. Into which table you want to insert, you write that. Values in parenthesis, you need to give the values for that particular tuple. How can a tuple T in relational model can be seen as? It can be seen as sequence of values like this. Okay, so that's why I should give the values in a particular order, and then the domain should also match. Then that particular tuple will be inserted into the table which is specified here at the table name. For example, I want to insert a tuple into the department table where first one is the department name, second one is the department number, and third one is the manager, and the next one is his start date. So now insert into department table values, first value, second one, that is V1, V2, V3 and V4, and these V1, V2, V3 are from the domain corresponding to attribute 1, attribute 2, attribute 3, so on and so forth of department table. This is how we can insert tuples or rows into the table as and when needed. Then we can delete tuples as and when required. Delete from, this is the general format, delete from the table name, and I can also specify some condition. For example, I would like to get rid of all the tuples from department, that is I would like to eliminate a tuple for department number 10. Delete from department where the D number is equals to 10. It will remove the tuple with the department number 10 from department table. And if we don't specify any condition in the where clause, then it is going to behave in a different way. Suppose if I have delete from DEPT and end this statement here, since there is no clause or condition specified in where clause, since there is no where clause, and all the tuples in department table will be evaluated to true, and it will eliminate all the tuples. So one should be very careful when applying this delete operation. If you don't specify a condition, then all tuples of that table will be deleted. Of course, the structure of the table is there, because to get rid of the structure of the table or the table itself, we need to use the drop command, which is part of DDL. The DML will not work there. Using DML, we can only manipulate the data contained in the database. We cannot alter, or we cannot delete, or we cannot drop the structure or definition of the database objects. It is not possible. Then similarly, we can also update values under some columns for tuples for some relations. Suppose I would like to update the salary of employee with the SSN 141 to 60,000. How can I do that? Update employee table set. The set is the keyword that need to be used. Set which value of the which attribute value, salary attribute value, what is the new value 60,000, and for what kind of tuples in employee, that need to be specified in where clause, where SSN is equals to 141. And if I don't specify this where clause, and if I simply say, if I don't write this and then end the SQL statement here, then all tuples in employee table will evaluate to true, and automatically for every employee the salary value will be set to 60,000. So we need to be very careful about that. Now let us discuss another very important feature of SQL, which is called as a view. A view in SQL is a single table that is derived from other tables. These other tables are known as base tables. A view does not necessarily exist in the physical form. It can be considered as a virtual table. That's why views are considered as virtual table. They will not occupy any space permanently in the database. The tuples of base tables are actually stored in the database, and this limits the updates on the views. That's why, because they are virtual tables, and at the same time a view may be based on many base tables. That's why this due to this reason it becomes complex when we apply update operations on the views. That's why this limits the updates on the views. In fact, when a view is updated, the corresponding base tables are the structures which are to be updated. Because a view is a virtual table, it really does not exist in the database, and whatever data you see as part of the view is actually taken from the base relations or base tables. That's why whenever you make updates, that will correspond to the tuples in the base relations. That's why it is a very bit complex talks. That's why many database management systems, they will restrict or limit the operations with respect to updates on the views. This makes update operations on views more complex. It is like this. This is how we can define a view. It is also a DDL kind of command. Data definition command. Create, view, these are the keywords. I can give like table name, whatever name you wish to give to the view, you can give. And what should be the structure or schema of the view, that can be defined or that can be specified using this select statement. Select name, salary, D name, age, D location from employee and department, and where D number is equals to D number, and whatever is the result of this query, that will become the schema or that will become the structure of the view. That becomes the data of the view. And whenever the view definition is executed, the new temporary table is generated on the fly with specified attributes from specified base tables or base relations. View definitions are stored in the database, not the result of the view. The result of the view will be temporarily available in the database. Once the query on the view is over, the result or the views are gone. That's why they are called as virtual tables. And from then onwards, once you store the definition of the view, then onwards a view can be seen as a table and queries can be posed on it as if you are working with a normal relation or a table. Let us have a look at one example to have a better idea or understanding about this concept of views. Okay, I have employee table original tables that are available in the database, department table, and I have employee ID, e-name, age, and then D number, DNO, that is the foreign key here in employee table, and I have D number, D name, and location. Now, for some end user or the program, and if we recall our knowledge about the 3 schema architecture of the database, we have described the database at 3 different levels of abstraction. The first abstraction level, of course, it is external level. Next one is conceptual level. The next one is physical level. That is, every database will have only one conceptual level schema and then one physical level schema. Of course, it can have any number of external schemas depending on the requirement. How we are going to define the external schemas? It is in the form of views in the relational data model. So that is why you have some tables available in the conceptual schema or relational schemas, and I can define these views and I can make some of these relations exposed to some particular application, and using these we are going to implement the external schemas, or we are going to realize the external schemas using the view facility that is provided by the SQL. Okay. Now, the requirement is a particular end user or a program wants a table which contains only employee ID, employee name, and location where he works. How can I find out the location of an employee? It actually depends on his department number. Every department is located according to this schema structure of the database. Every department is located at a particular location. For example, 10, 20 and 30 are the departments. First one is accounts, second one is marketing, next one is HR. It is located in Chennai, second one is in Mumbai, and third one is in Hyderabad. Let us assume like that. So, I want to, for every employee, I want to find out what is his employee ID, not find out. I want this, a particular end user or the application program wants this data. Only employee ID, name, and location where he is working. That is where his department is located. Only this much data is sufficient, and actually in the conceptual schema of the database, let us assume that you have employee table, department table, along with other tables like a project table and then works on table, dependent table. All these things are there at conceptual level. Now, a end user or external schema 1 need to be in this format. Then I can specify that schema using a view definition. I can do this, I can achieve this with this definition of the view. Create view, I am giving it a name employee emp underscore location. What should be the structure? What data should appear in the view? As create view emp underscore location as select EID, ename, location from, because where can I get EID and ename are available in employee table, but where can I get this location from which relation I can get it? I need to get it only from the department table. First I need to join the tuples across this employee and department based on DNO. Then I need to figure out what employee's working location is what place, that I can get. So, create view employee location, that is the name of the temporary table or the view. A view can be considered as a temporary table. What should be the structure? What data will be there? This will be the data that will be there in this table. Select EID, ename, location from employee department, where DNO in employee is equal to D number in the department table. Okay. Once you do this, this definition is stored in the database data definition or along with the metadata in the database. Like how you have definitions for tables, constraints are available in the metadata or data dictionary or system catalog. This definition of the view is also stored in the database. And once you are done with this view, then it is not going to create the table permanently. The tables or the data for the view is extracted from the base relations. In this case, what are the base relations? The base relations are employee table and then department table. As and when required, the definition will be executed, evaluated, and the temporary table is constructed, and that view can be treated as if it is a normal table, and then normal queries can be posed on that view. For example, let us assume that we have created a view by name emp underscore location. That definition is available in the database, and that has been made available to the end user, to some application program, okay, as a external schema, as part of external schema given to that particular end user. Then from then onwards that application or the end user treats that view as a normal table, and he can pose queries on the table as if he is working with any other normal relation or a table. So, he may not be knowing whether it is a real table or the view, then he will pose a query like this. Let us assume that select EID, ENAME, and we have made this schema open or expose it to the end user. So, he can write queries on this view. Select EID, ENAME from EMP underscore location, where location is equals to Mumbai. That means in his application program, he wants the employee IDs and then names who are working at Mumbai location. And when this query is executed, automatically this query engine will try to find out the table to extract the data. When it consults the data dictionary in search of this table, it understands that this is not a normal table, rather it is going to be, because there is no actual table or relation that has been created with name EMP underscore location. And in this specific example, I have only two tables. First one is the employee table, second one is the department table, and when it consults the data dictionary, it clearly understands this is not a normal table, rather it could be a view. Then it will search for the definition of that view. Automatically, since the definition of the view, whatever is given here is already stored in the database data dictionary, then automatically it will execute that view definition. When the view definition executed, then and there itself the temporary table is generated with employee ID, employee name, and then location. From this temporary table, it will extract those tuples where the location is equals to Mumbai, and that will be given as a result of this query, which is posted on the specified on the view. So, this is how, that is as and fly, on the fly, as and when it is required, the view definition is executed and the temporary table is generated, and the query, the result or data can be extracted from this temporary table, and once it is done, it will disappear. So, that is why it is a virtual table. The views are called as virtual tables. Very important point to be noted is, a view is always up to date. Updates are generally not possible on views because it is more complex. Of course, if some conditions are satisfied, that is, if a view is actually created or specified only on one relation, it could be possible, and if the view includes a primary key attribute of that base relation, then also it can be may be possible. So, that is why anyway most of the time these views are meant for only querying purpose. Generally, we will not perform update operations on these views. Sometimes it is possible to store views for some time depending on the requirement. Suppose if there is an application which is executing a query which is specified on a view very frequently, in a minute 4 times or 5 times, in that case every time what happens, it is a not a permanent table. Hence, if you want to extract the data using that query which is posed or specified on the view, every time the view definition need to be executed. That will become a very costly process. Hence, sometimes some database management systems, they allow to store the result of a view, that is view definition, that is the data of a view temporarily in the database for some time. Such kind of views are known as materialized views. Some database management systems support this. Then what happens? It is going to increase the efficiency. Since the result of first time evaluation of the definition is already stored in the database, next time onwards, whenever a query is posed on the same view, then automatically the same data can be consulted, and then the data can be given to the user. Okay, now let us have a look at some example query statements written in SQL to extract or retrieve data from this company database. You have employee table, department location, project, works on, and dependent. So, now we will try to write some queries based on this. The first requirement is such that we need to get the list of employee IDs who have no dependents. I can write the query like this: select SSN from employee where SSN not in, select ESSN from dependent. There is a nested query, and it is not a correlated nested query because I am not referring to any of the attributes which belong to outer query relation. So, this one time execution of this query is sufficient, and select ESSN from dependent, it will give you the ESSN values from the dependent table. If at all a SSN is having at least one dependent, his SSN will be available, must be available in this list. So that's why I am using that logic to solve this problem. Select SSN from employee table where SSN not in. If the SSN, suppose the SSNs who have dependents are 101, 108, 110 and 114, and if I am checking for 110, it will not in will evaluate to false, so he will not show up in the result. If it is 106, this value is not there in this, hence it is true, and for such employee the SSN will be displayed, because I would like to know who are the employees who are not having any dependents. Okay. Similarly, I can write the same data retrieval with different way. Select SSN from employee, that is, it will give you the set of employees IDs. Select ESSN from dependent, it will give you the set of employees who are having at least one dependent. Then I can use the minus operation or difference, which is specified using the keyword except. That will also give you the required result. The second query is get the list of employee IDs who have more than 2 dependents. In this case, of course, I need to use the group by operation. Select ESSN from dependent table, group them by ESSN. If a employee is not having any dependents, his entry will not be there in the dependent table. If he is having 2 dependents, if I am grouping the tuples in dependent table based on ESSN, that for that particular employee group, it will have 2 tuples. If he is having 3 dependents, suppose 102 is having 2 dependents, 110 is having 3 dependents, like this. After doing this grouping based on ESSN, I can apply having clause. The having clause is applied on individual groups. It is nothing but checking for some condition that should be satisfied by individual group. After grouping, I will check count star, meaning that what? When I am using having clause or aggregate function, first grouping is done, then these aggregate functions will be evaluated on individual groups. So when I use count star, it will check how many tuples are there in each group. If the count is greater than 2, that indicates that that particular employee has more than 2 dependents. For such employee, the ESSN will be displayed in the result. Then get the list of projects controlled by department with name accounts. I can answer this in 2 ways. Select P number and P name from projects, where dnum, which is a foreign key in project table, which refers to the d number in the department table, where dnum in I have written a nested query. This nested query, is it a correlated nested query? No, it is not a correlated nested query, because I am not referring to any attribute which is part of the outer query relation. That is why the one time evaluation this is sufficient. Let us assume that there is a department with a department number 10 and whose name is accounts. So the result of this is going to be 10. There is only one element. For every project in the project table, it will check whether the dnum, which is the controlling department, is in this set or not. If it is there, for such project, it will display the project number and then P name. This will give you the list of project numbers and then project names which are controlled by accounts department. Otherwise, I can also write it like this also. Select P number, P name from project comma department, and the joining condition is where dnum from project is equal to d number from department, and the other condition is from the joined tuples, the condition that need to be satisfied is where the d name is equals to accounts. If it is satisfied, I will pick up the P number and P name and show it up in the result. Get the list of employee IDs working on all the projects available in the company. I can solve this by using group by operation. Select ESSN from works on table. The works on table will give me the information about what employee is working on what project. Okay, if there are 5 projects available in the project table, okay, P1, P2, let us consider only 3 projects. And then if there are 3 tuples for a given employee in the works on table, that indicates that he is working on all the projects. If there are only 2 tuples in the works on table for a given employee, it indicates that he is working on only 2 projects. Using that logic, I am going to solve this problem. Select ESSN from works on table, group by ESSN. That means I am grouping the tuples in a works on table based on ESSN. On individual groups, I am applying this. I am counting how many tuples are there in each group. If the number of tuples in each group is equal to number of projects, how can I get number of projects? It is equal to number of tuples in the project table. That is why I have written a nested query, which is not a correlated nested query. Then for each project, for each employee in the works on table, group them based on ESSN and count how many tuples are there. And if there are 3 projects, this particular thing, the result will be equal to 3. And then if the count star is equal to 3, that indicates that the given employee is working on all the project. For such employee, you can display the result in the result, display the ESSN in the result. I can also write this in this way: select E dot ESSN from works on as E. This is aliasing, where I am writing 2 nested queries. Select PNO from works on, where ESSN is equals to E dot ESSN. The first one is a correlated nested query, because E dot ESSN belongs to this, contains select P number from the project. This gives you a set and this gives you a set, and the second one is not a correlated nested query. This will give you the set of projects that are available in the company, and then every time for every employee you will find out what are the P numbers. So if the first employee 101 is working with only P1 and P2, this will be there in the result for that employee as result of the first nested query. And does this contain this? No. This contains operation or contains clause will check whether all the elements available in the second set are contained in the first set or not. If it is so, then only it will evaluate to true. In this specific example for 101, he is working with only P1 and P2, and this set will not contain all the projects. That's why his ESSN is not showing up in the result. Suppose if 110 is working with all P1, P2 and P3, then the first result of first query will be P1, P2, P3. This contains this. That's why 110 will show up in the result. That is how we can use this contains clause. Find the projects controlled by departments located in Mumbai. Select P number, P name from project table, where dnum in project is equals to select D number from department locations, where D location is equals to Mumbai. If you look at this inner query, it is not a correlated nested query, so you execute that any number of times. If the department 10 is located in Mumbai, then the result is going to be always 10. For every project, you check whether dnum is in this or not, dnum is equals to this or not. If it is so, then you show that P number and P name in the result. Next one. This is about updating some tuples. Update the salary of those employees who are working with the department HR to 20,000. That is, I want to change the salary of employees who are working with the HR department flat, that is 20,000 for all of them. Update employee table, set salary is equals to 20,000 for whom, where the D number must be same as the D number of HR department. How can I get that? I write a correlate, it is a simple nested query. Select D number from department table, where D name is equals to HR. Suppose if it is equals to 20, for every employee check D number is equals to 20 or not. If it is so, change his salary to 20,000. This is about update. Similarly, we can delete some tuples depending on the requirement. Delete the records of employees who get salary less than 5,000. Delete from employee where salary less than 5,000. So it will go to employee table and then check the salary value whether it is less than 5,000 or not. If it is so, it will eliminate all such tuples. And if you simply write this, it is going to eliminate all the tuples independent of the anything. There is no check, there is no condition that need to be satisfied. Hence, all the tuples will qualify, and then all the tuples will be deleted from the table. Okay. In this session, we have covered how to write nested queries in SQL. What is the meaning of a correlated nested query? Writing queries using the clauses exist, not exist, between and in, not in, and of course we have also covered the keyword contain, how to use the keyword contain. Then we have seen how to perform explicit join operations to perform simple joins, outer joins, natural joins. We have seen how to use the clause group by and how to use the having clause. And having clause must be always used in conjunction with group by, and wherein after grouping you are going to apply some check or test for some condition on individual groups. Then we have seen the concept of views in SQL. Views can be seen as temporary tables or virtual relations or virtual tables, and as and view definitions will be there in the system catalog. As and when required, when you pose a query which involves a view, then the view definition is evaluated, the temporary table is generated, and the data is extracted from the table, and once it is done, it disappears. And we have also seen some examples on SQL using various features. Let us stop here. Thank you very much.